So this is the second half of our final exam review. We're going to start here with a polynomial inequality. Now, when we solve a polynomial inequality, the first thing we want to do is we want to find the roots. So to find the roots, we set each factor equal to 0, the same way we did same way we would if it was a polynomial equation. Now, for a polynomial inequality, I'm going to draw myself a number line. And I'm going to plot those 3 points. I want them to be in the correct order, though. Because this is strictly greater than, I'm going to put open circles on those 3 points. Had it been greater than or equal to, I would have put closed circles. Okay, had there been an or equal to, closed circles, no or equal to, open circles. And now what I'm going to do is I'm going to test values. What I've done with these circles is I've broken this graph up into sections. There's the section to the left of -11, in between -11 and -8, in between -8 and 3, and to the right of 3. And I'm going to test a value in each one of those sections and see what happens when I plug it in. I want it to be greater than 0. So if I test a number and that when I plug it in, it is greater than 0, then I'm going to shade that section of the graph in. When I test a number, if I get a number less than 0, I'm not going to shade that section of the graph in. So let's see what I mean. A number to the left of -11, let's test -15. And when I test -15, I'm going to plug it in. So when I plug in -15, I get -1008. Is it true that -1008 is greater than 0? No. So that means I'm not going to shade in the section of the graph with -15. Now let's test a value in between -11 and -8. How about -10? And any number in between -11 and -8 would work. So if you'd done -9, negative whatever, anything in between -11 and -8 would work. This time I got 52. And that is true. Now, since when I plug in a number in between -11 and -8, I get a true inequality, I'm going to shade in that section of the graph. Okay, let's test between -8 and 3. I'll do 0. So when I plug in 0 here, I get -528, which is not greater than 0. So I'm not going to shade in that section of the graph. And so now I'm going to test a number to the right of 3. Let's try 5. Any number to the right of 3 would work. So you could have also done something like 500 if you want to, as long as it's to the right of 3. Now, when I plugged in a number to the right of 3, I also got a true inequality. So I'm going to shade in the graph to the right of 3. And then my request to you is just to make sure that you double check and triple check what format they want this answer in. Because if they want this as an inequality, then you would say -11. I was about to write interval notation. -11 is less than C is less than -8. And C is greater than 3. If they want interval notation, then you would say -11 to -8 and 3 to infinity. Okay. I honestly, like, really genuinely don't know which format they're going to ask the final asks for. So make sure that you are reading and make sure that you're aware of which one of these two it wants your answer in. Because if it asks you for an interval and you give it an inequality, your inequality could be correct, but you're not going to get credit because you didn't give it in the right format. Okay. So just make sure that you're reading very carefully. All right. Now for the next one, when we're solving a system, I think I still have this matrix in here. I do. So when we're solving a system, we're going to turn this into an augmented matrix by taking out just the coefficients and putting them in a matrix. So I already have this one in my calculator. But remember, to get here, we go second and then the next to the -1 to get to matrix. You do your dimensions first, so 4 enter, 5 enter, and then put in each one of your numbers, pressing enter in between as you go across. Okay? Then you go back to matrix, over to math, and you scroll down until you get to RREF, not REF, RREF. Press enter, back to matrix, and enter on A because that is where you have your matrix stored. And now here, if we go X, Y, Z, W, then this is X, Y, Z, W. So I have X equals -2, Y equals -3, Z equals -3, and W equals 2. Okay. Right. So for the next one, it says in 1995, the moose population in a park was measured to be 6,300. By 1997, the population was 6,600. If the population continues to change linearly, find an equation for the population T in years since 1989. That makes me mad. It's annoying because they gave you 95 and 97. So why start at 89? But whatever. If we're starting at 89, then 1995 would be 6 years later. And so 6 years later, there were 6,300 moose. And then 1997 would be 8 years later. And 8 years later, there were 6,600 moose. Now, you could absolutely find the slope and then plug it into point slope and then solve y. Sure. Or we can make the calculator do a little bit of work for us. So go to stat and then enter for edit. And let's put in these 2 points. 6 and 8 are my y values. 6,300 and 6,600 are my x values. And then go stat, calc. This is linear, so we'll do linear regression. And then that means that we have P of T equals 150T plus 5,400. And that is my equation. Okay. So what does your model predict will be the moose population in 2005? Well, if we started in 1989, 2005 would be 16 years later. So we're going to plug in 16. And 150 times 16 plus 5,400, 7,800. mooses, meese, moose. Okay. All right. A quick note, this is asking you for your R and your R squared value. If you've gotten this far and your calculator is still not showing you R and R squared, then in order to turn on R and R squared, I know I said this like the day that we did this, but that was a long time ago. You press second and then 0 to get to catalog, second 0, and then you scroll down. It's going to be a little ways down to get to diagnostics on. I'm almost there. There we go. So if you press enter on diagnostics on and then enter one more time, if your R values were not showing up before, they will show up now. Okay. So we want a linear regression that shows the relationship between the number of thousands of registered automatic weapons and murders per 100,000 residents. Okay. Stat. Back to edit. You can just press delete and that'll get these values out of there. So 11.3, 8.1, I missed a 1 up there. 11.3, no, 11.3, there you go. 8.1, 6.8, 0.6, 8.3, 2.3, 2.5, and 0. Okay. 13.7, 10.8, 10, 1.3, 5.7, 6.2, 6.5, 4.5. Oop, what happened? Oh, I somehow went over my 8.1 by accident. Okay. 0.1, 6.8, 8.6. There you go. Okay. And then back to stat. Over to calc. They have told us that they want a linear regression. So we'll go back to linear regression, just like we just used. 3 decimal points means that my regression equation will be h of w 0.855 w plus 4.0. This 9 is going to round this 9 up, which is going to round this 5 up. So 4.06 would be 3 decimal places. It's really 4.060. And then R is 0.997 and R squared is 0.995. Okay. Using your linear regression, how many murders per 100,000 residents can be expected in a state with 3,500 automatic weapons? Now, they round that 3,500 to thousands. So when we put it in, we're going to make W 3.5. So then H of 3.5 is going to be 0.855 times 3.5 plus 4.06. I'm just going to put that in my calculator. Round to 3 decimal places. 0.53. See. Okay. How many automatic weapons would be expected in a city with 10 murders per 100,000? So that means that H is 10. So I would say 10 equals 0.855 times W plus 4.06. Subtract the 4.06. I feel like I should have known that that was 5.94. And then divide by the 0.855. Now here's the thing. I get this answer right here. But remember, this is in terms of thousands. And they're asking us to round it to the nearest whole weapon. So this is 6.947 thousand, which means that it would be 6,947 weapons. Because just like here, when I had to move the decimal point 3 places, I have to move the decimal point back 3 places here. Okay. I feel like this is an easy half. All right, average rate of change is just a fancy way of asking for slope. So whenever they ask you for average rate of change, these are the X values. You're given the X values and you have to find the Y values. So if you're given a graph, then you're just going to say, okay, at 1, my graph is at 0. At 2, my graph is at 4. Now, had they given you a function, you would have plugged these two values into your function to get your Ys. Had they given you a table, you would have used your table to get your Ys. Okay, so just make sure that you can get Ys if you're given X's in any form. And then we're just going to do slope. So 4 minus 0 over 2 minus 1 is going to be 4 over 1, which is just 4. So the average rate of change from 1 to 2 is 4. And I mean, you could have figured that out by just saying, hey, it went up 4 over 1. But, you know. Okay. I'm going to use the calculator for this one again. So back to stat, edit, delete everything that's here. My two X values are 4 and 7. My corresponding Y values are 1 and 13. Press stat, calc. The first thing that they ask for is linear. So let's do linear first. So linear is Y equals 4X minus 15. And then to do exponential, you're going to go back to stat, back to calc. Exponential regression is just off the screen. There it is. With the same 2 points to 4 decimal places, 0.0327 to the 2.3513. Okay, 0.0327 times 2.3513 to the X. Okay. A note about this one that some of you guys stumble on your homework. If you see this word continuous, then they want A equals PE to the RT. If you do not see the word continuous, then they want A equals P times 1 plus R to the T. Okay, but the word continuous means that you need to use the PE to the RT formula. Okay. A fox population in a certain region has a continuous growth rate of 6% per year. It is estimated that the population in 2008 was 18,800. So then we would say that the population is 18,800. Too many zeros. E to the 0.06t. And so in 2018, that would be 10 years later. So then we're going to do P of 10. And that I'm just going to put in the calculator. E I'm going to round to the nearest whole fox. Okay. And in which year will the fox population reach 25,800? So now I'm going to say, okay, 25,800 equals 18,800 e to the 0.06 t. Divide both sides by the 18,800. .3723. And then we need to turn this into a logarithm. And remember with the e's, anytime we turn an e into a logarithm, it turns into the natural log. So this would be the ln of 1.3723 equals 0.06t. Then divided by 0.06. The ln of that divided by 0.06. So this is 5.275 years later. So I want you to think about this. 1 year later would be 2019, 20, 21, 22, 23. And then the 0.3 would bump us up into 2024. Throw an extra number in there. Okay. All right. So here, when we're combining these logs, anything with a minus in front of it goes in the denominator. Anything with a plus in front of it goes in the numerator. So this would be log base 6 of, and then x minus 8 in the numerator, x minus 6, and x minus 4 in the denominator. And you could also think of it like this, where these are being added and then the whole thing is being subtracted if you GCF out the negative, if you're having a hard time thinking about it that way. Or you can just remember anything with a positive that goes in the numerator, anything with a negative goes in the denominator. Okay. So I very purposefully do not do all 6 pages on one night because I feel like it's a lot of information. So that is the second half.